All right, perfect. So today I would like to talk to you guys about content creation, but with a little help. So first of all, a little bit about me. My name is Bert Willems. I'm the product architect at XML, and it's basically my job to build products that actually solve some customers' problems. You can follow me at my Twitter account. It's Work, or just send me an email if you have any questions, or come talk to me in one of the coffee breaks. So first of all, a bit of background. I'm not going to talk to you a lot about the benefits of structured content and why you should do that. I mean, you guys are probably way more experienced than me. But one observation that I would like to express is that the content that is nowadays created is consumed increasingly differently. So right now we have dynamic publishing systems, we have web applications who generate personalized knowledge bases, for example. We have a lot of functionality when it comes to search and recommendation engines. It was based on full text, but now we can use the semantic web in there as well. And a fairly recent development, I would say, is stuff like chatbots and agents, where you can basically type in your question and software will try to find the answer for you and display that answer in a very conversational style of working. So what does that require in terms of content? So first of all, the content should be modular, which means that basically you chunk it down to reusable parts, so you can take the content and redistribute it in any way you would like. Second of all, the content must be interpretable. That's both by humans, of course. People still read stuff, as well as by machines. And the content needs to be connected. And what I mean by that is that it contains links. So a very basic example is, of course, a hyperlink, but it could also be a bibliographic reference. So content on its own it's no longer on its own. It's really a part of a connected network of other content and content modules. So challenges, of course, there are a lot. The panel discussion yesterday was all about challenges to go into this direction. I would argue that the format discussion, well, I would say that XML is pretty much the way to go. There's a lot of stuff going on there. We have things like XSLT that helps us transform the XML in any format that we would like. And stuff like that. So the ecosystem is quite mature, I would say. However, the amount of effort that goes into writing content. So first of all, you need to find someone with a particular knowledge, so a subject matter expert, if you will. Then you need to convince that guy or girl to actually start writing. But you also increasingly require that person to do that according to the rules that you set. So, for example, if you want to do the rich integration with triple store or something like that, you need some sort of triples to be encoded in that content, and that's all piles onto the into the effort that is required to build or to write well-structured content. So, a quick survey. Please raise your hand. Who has used spell check? Yeah, I guess pretty much everyone, not. Yeah, so spell check, the research started as early as 1975, so that's quite early, and the early first commercial application was in 1981, according to Wikipedia. It was part of an IBM shipment. So my point is that we could also use a little help. I mean, it's very easy to make a typo, and it really helps me, even though we're all quite familiar with English. It's still hard to really write the ideas, and mistake is easily made. However, things like spell check really help us to fix those pesky, annoying little problems for us without needing someone to proofread it for us. So the machine can aid a lot in that. So the question that I would like to address is basically, can the human and machines, or software if you will, co-create accurate and consistent content? So can we reduce the amount of effort that is required to write that accurate and high quality content? Yes, I think we will be able to do it. Do we need this guy? Well, I think the user interface and the user experience can be a lot better, but for all intents and purposes, I would say yes, we could definitely use that. And you could think of this guy as the guy reading our document and putting in the red squiggles, which indicate a spelling error, but it could also indicate whether a link is broken, for example, or you could think of this guy as using schematron rules and checking your document with those schematron rules. So yes, we definitely could use some help in a form of a digital assistant, but of course it needs to be smarter, actually helpful, and less annoying, of course. So how can we do that? Well, in recent years, well, in the last 40 years, I would even say there is a lot of development going on in research in the academic space about well, machine understanding, just making software aware of the world around us. And in the last couple of months, I would say, there are a lot of practical applications, so real-world applications surfacing based on that research. So I'm not sure if you use it, but I definitely did. I went on a holiday to Chile beginning this year, and I don't speak any Spanish, and the menus were in Spanish, so I took out my cell phone and I got this Google Translate app installed, and I was just holding the menu in front of me, pointed my phone in it, and it recognized the text. Then it translated it and rendered the text as an overlay in my preferred language, which was in this case Dutch. And that happens almost instantaneously. So, and that's all based on image recognition, that's based on translation. I mean, translation is quite hard, but the point is that there is a lot of research going on there, and that's fairly successful, I would say. So, can we leverage that research? Can we leverage all that experience, all those scientists that did that hard work and made sure that the individual algorithms that have been developed in that area, that we can use that in the world of structured content authoring? And what does that mean? So first of all, I think we need to integrate with semantic technology. It could be as simple as integrating like a thesaurus or a knowledge graph, if you will, into the structured content. Can be fairly simple. I mean, if you have like a name of a person, we could point that to the digital object identifier representing that person. A very important component is the natural language processing. I mean, in the end, structured content is a lot about text. So we need to be able to understand text, and that's what the field of natural language processing does. It tries to understand text on various levels, and I will give a couple of examples later. And then we can basically apply machine learning techniques. And I'm not going to dive in too much detail. I think there are tons of conferences out there dedicated to machine learning, so I will just give a quick overview later on to give you an idea on how that works. But the vision that I have is that we need this kind of loop, as I call it, the structured content feedback loop. On the top, we have the subject matter expert, or the human, if you will, who writes structured content, or content in general. The content can be used to build a knowledge model based on that. And from that knowledge model, we can start to infer suggestions or improvements or inconsistencies back to the subject matter expert, so he or she can decide whether that actually makes sense. It's kind of abstract, so let me go into a concrete example. So I would like to take you on a quest to find basically all the nodes in a given text while doing as less work as possible, because yeah, basically I'm lazy, right? So we're going to build a structured content loop which classifies all the nodes in a given text. So the structure and the semantical quality of the text goes up, and again, without any effort. So we're going to use these two, well, not even documents. I'm making a very simple example here, distilling it to the bare essentials to illustrate my point. But we have two sentences, and obviously the warning, do not try this live at a conference, of course, is something you would tag as a note. I think this did a schema, not sure. It doesn't really matter what schema you have, but we all know that that sentence warning is something that's relevant. And probably if we're going to publish this, there's going to be a red box around this and maybe a sign next to it as well. So this is the challenge that we would like to solve. So first of all, since it's an XML conference, let's look at schematron. This is quite a good fit to solve this particular problem, right? So a very simple rule. Hopefully I wrote this correct. I'm definitely not a schematron expert, but bear with me. So we got a very simple rule that says I'm going to match all the paragraphs, and I'm going to check whether that paragraph starts with the word warning followed by a colon. And if that is the case, I generate a warning to the author to inform him or her to actually tag this properly, in this case the node element with the type or with the attribute warning. And schematron works quite well in this scenario. I mean, we also have schematron quick fixes. I'm sure that most of you will be familiar with that, but it basically allows you to write an XSLT, I believe, to solve this problem. So the XSLT would be to wrap this sentence inside the node element, or perhaps replace the P element with a node element. But there are a few issues with this approach. So first of all, it's very specific to the warning pattern. What happens if someone writes the sentence a bit differently? Maybe it's just don't try this at home, then there's no warning prefix to filter on. And of course we could use technologies like regular expressions to do a bit more, a bit smarter matching. Jirko, you displayed or yesterday in your presentation you showed a couple of ways of doing that, including defining a custom grammar and compile expressions from that. And that's definitely an option to scale this out a bit more. But it's still, the second point is that it still requires you to write the rules. So you have to be basically a schema architect or the schematron writer needs to go talk to business, figure out, look at the content, figure out what the exact nature of the issues are, then write the schematron rules, put that into production, use a start and act because maybe a case was written not specifically enough, so it triggers a lot. All the problems that we yesterday heard in the panel discussion as well. And the third part is really it's machine to human only. So you can report to schematron, but you cannot say to schematron, no, you're wrong. So, and that will, sometimes it may lead to frustration or perhaps even worse, ignorance. So people start just to ignore all the warnings because someone else might solve the problem, right? I'm not saying that schematron is not a useful technology, definitely not. I mean, in a lot of use cases, it makes a lot of sense. And probably in a lot of organizations, these issues, well, can be solved if someone's on the, someone is capable of doing that. So, this quote It basically says that why write any code if we can learn? And I'm saying here that we can replace we with software, and that's basically what machine learning is all about. So let's have a look, and I need to speed up a little here, about how that would work. So first of all, we're going to going through a few steps to basically avoid the first problem of having to write very specific rules. So bear with me, I'm going to come to a conclusion on this later, but the first step that we do is basically part of speech tagging, which means that for every word in a sentence, we're going to apply the lexical category on that. So we have verbs in there, we have nouns and stuff like that. And I'll show later why that's useful. The second step is named entity recognition, which basically is finding persons, locations, times, stuff like that inside a sentence. So in this example, you'll see that do not try this live at, and then a location is tagged as, a conference is tagged as the location. So we know that that is the venue where it takes place. So, and then we can do pattern abstraction. And this is where I'm combining both the part of speech tags as well as the named entities to build these kinds of abstract representations of the sentence. So again, it's very, very common to regular expressions, but it's not just on the character level, it's also on the semantical level and on the lexical level. So what I did here is I left in a couple of words, so do not. Then I inserted a placeholder, if you will, that says whatever comes here, it must be a verb. Then I have a wildcard, so there could be any amount of words there, doesn't matter the category. Then I have the word this, again hard-coded in this pattern, and wildcard, and then we have the location. So whatever the location is, as long as it is a location, it will be fine. So that means that the sentences below will be matched by this pattern. So that shows basically how we can avoid or abstract away a lot of the very specific patterns that we saw in the schematonics example. So let me move on to the second point. That is actually finding those patterns, because still in the previous step I still had to write the patterns. They were more abstract, so there were probably less of them, but I still had to write it. So what I'm doing here is I basically take a large volume of content that is already properly tagged. It has been checked by humans, and take that as our input. So that ties a bit into the discussion that Debbie, or the point that Debbie raised yesterday about if you want high quality content and if it's valuable to you, you have to bring in the pharmacist or the graduates to properly tag the documents. So assume we have a large content body of content already that's of high quality. So what we do then is we take that body of content, throw that into a machine, and the first step that the machine will do is basically extract all these sentences from it. Very simple, right? And then we apply basically the same steps as I showed you before. We're doing part of speech tagging, we do named entity recognition, we could do a couple of other smart things. But that's not really the interesting point. The interesting point here is the pattern generalization. And what I mean by that is that if we have two patterns that are very similar to each other, I'm going to calculate that. And there's tons of research going in there. It's a lot of math. So I won't go into too much detail here. But basically, I'm finding abstractions for those patterns. So I abstract those patterns away. So that gives me a set of patterns. So how can we map that? Remember, we're having these properly tagged documents we're putting into the machine. So we now have patterns, and a lot of them, they're abstract. And what I can do now is calculate the likelihood of a certain pattern occurring in my example content set or in my training data set. I calculate basically in which elements it's most likely to occur. Again, this is a quite straightforward example. There could be a very elaborate mechanism here as well. But you can basically see an abbreviated T pattern, but the pattern do not verb occurs 20 times inside the node element and only 2 times inside the piece. So with a bit of math, I can say that I can be 90% sure that if I recognize that pattern in the wild, in a unclassified document, I could say I'm fairly confident that it should be tagged as a node. So again, I'm skipping a lot of steps here to explain the actual details, but that will take hours and hours to explain. But for all intents and purposes, we have found a way to automatically find the patterns and define rules based on that. So let's look at the last problem, machine to human readable. Because, like I said, we're only 90% sure, right? We could be wrong. Yeah, what we're going to do then. So the important thing is that we don't want to be like Clippy. We don't want to be annoying. We don't want to automatically fix things and make it even worse. So what I would like to propose is to feed that information back to the original author or to the subject matter expert, who can make an expert decision on whether it actually makes sense to tag this as this. Right? It could be as simple as a yes or no question. So let's close the loop now. And the point is that regardless of whether we click on yes to accept the suggestion and apply to the XML, or if we click no, it's valuable to the machine. Because if I click yes, it will enforce the pattern. Remember that we had 20 occurrences, then we have 21 occurrences. And I can't do the math faster enough, but the certainty will go up by, I think, 2% or so, maybe. But even if the suggestion is rejected, so it won't be in the XML training set, it is still valuable because it can act as a counterexample. And what that essentially means is, again, in this model, is that we're not having only this loop, but we basically have a secondary loop which says if the subject matter experts reject a particular suggestion, we feed that back into the knowledge model as well. And what we basically do is we do the same enforcement of certainty, but only in a negative sense. So instead of saying, well, I was 90% sure, well, maybe the machine becomes a bit more doubtful and say, meh, the next time I'll be like at 70% or so. So to come to the conclusion, although we went quite fast through the materials, I think that the structured content loop enable humans and machines to co-create consistent, high-quality information. And the last part is very essential in a changing world. This means that we continuously improve the models that are behind there. We continuously improve the representation of the world, if you will, that we try to describe in the structured content set that we're actually authoring in this particular case. Thank you very much for your attention.
Thank you, Bert. Do we have time for questions?
Yeah, thank you very much for kind of showing us this, because yesterday I've been just talking to some other friends during the social event that it's pity that no one still combined kind of machine learning, natural language processing with kind of XML tagging, because it can give much better results. And my question is it just kind of proof of concept or idea, or do you have some like system which can just digest large amount of already marked up content and just suggest rules? We will just overview them and feed them into the editor. And so how much this is kind of...
Yeah, so basically the question is, how far are you actually implementing this stuff?
Yeah.
Okay, a few observations there. So first of all, our company is focused around the user experience. So what we're currently doing is building or designing the user interface that basically allows you to make the decision basically help the human understand why the machine suggested this and to make the decision. And it could be, of course, be ambiguity stay there that the user needs to decide. So that's one area that we're currently working on. The second point is that there is a lot of stuff going on that that it would take basically forever to implement. I mean, in the sense that if we need to do it ourselves. So, for example, Google or Microsoft are putting now hardware accelerated algorithms into the data centers and make it available as REST services, for example. So what we're envisioning is not building this, all the engine and all the algorithms ourselves, because a lot of this is already based in existing research. There are products out there that can already use it. So what we're going to do is we're going to take those services and combine them with some of our own services and make that available to the user. So to basically a long answer, I would hope to be able to demo this next year in a working application.
In February?
It's usually our CEO who promises things to customers, but in this case, yeah, I will make this work.
He means take-home.
Yeah, exactly.
Reason to be in Prague. You like Prague? Okay, go
I
to
thought you were
Prague.
referring to take-home.
Any other questions?
So you're referring to XML London, right?
Of course it was.
Of course he was.
Okay, thank you very much, Bert.
You're welcome.